As I promised, we're going to start modeling in a lot more detail to the helmet in this tutorial. We're going to model in the insets that exist just along the sun visor brim of the helmet. We're going to do the major inset with the rounded back to it in the middle top section of the helmet, and we're also going to go ahead and bevel some of those sharps that we marked along the sides and back of the helmet. So we're going to get a lot more detail, we're going to get a lot more profile to the helmet, so you should be very excited for the results we're going to have come the end of this tutorial. So this little part that we've done the inward extrusion on, not all the faces around it are actually evenly spaced from the bottom of it to the top of it. So what we're going to do is, after we dissolve this outward edge, is we're going to select the bottom two edges, grab the normal profile of that so that we can do a rotation around it, set the 3D cursor to the selected point, and then use our 3D cursor as the origin. This is going to allow us to rotate all of these faces that we've just done the inward extrusion on and make the design look a little bit more interesting and less flat as it is currently. We're going to do the rotation along the local Y axis, and then we're just going to continue to modify the depth of it and the profile of the surrounding edges. I'm not entirely sure how, but I've ended up with doubles in this part of the model, and that's why I've got those red edges at the corners of the mesh here. It's really easy, I just need to go ahead and remove the doubles in this area. Not sure why that happened. If you guys get the same results by any hand, just do exactly as I did, and that will fix up the inconsistency. So, as I said back in episode 2, we can try our best to keep our topology in line with some of the more major forms of detail on the helmet. However, as you can see, I've done an absolutely horrible job of that, and the sharply marked edges that I have there are nowhere close to being in line with this detail. But if yours has ended up in the same way, don't worry, we can go ahead and fix it up now by just cutting in a new set of vertices and edges along the design. Doing my spacing operations along this part of the helmet, I'm going to be more conscious of where I've just cut that detail in and use that set of vertices we've just cut into the helmet as the last part of the selection to do the space operation between. As I said earlier on in this tutorial series, we can use this harsh red matte cap to find areas of pinching around our model. And as you'll notice, just where we've done that inward extrusion on the top part of the helmet, we've got pinching just on the upper left-hand corner. So all I'm doing there is just using an edge slide to push this one vertex further into the design and just trying to flatten out the severity of the pinching. Despite having just a few minutes ago gone and fixed up the topology to line up with this inset along the side and top of the helmet, I have once again just gone and screwed it up. So as I tried to stress very early on in this tutorial series, if you don't keep this lined up all the time, it's of no big deal because I've literally just gone ahead and screwed it up twice, but the results still turn out fine, as we can always just go back and cut the details back in so that the topology lines up again. What we want to do here is with the edges and vertices on the outer limits of this inset detail, we just want to try and line them up with the details on the inside. It will just make the whole merging process later on a lot easier, as you might have a very minute discrepancy, but it won't be anything major, and it just means you have to do far less cleanup, and it's much easier to do this while the two meshes are still somewhat separate from one another, as opposed to later on when they will be completely merged together and all joined. You'll notice on the corner of the details here where the panels that we've modelled in the middle there connect with the sides of the inset details. It sort of has like this weird stretching and odd look to it. It's got a bit of a distortion to it. That's because we have a pole there. So what we're going to do is go ahead, select these edges and just do an edge slide towards it just to tighten up all the details and get rid of that discrepancy. Okay, so we're just going to go ahead and remove the sharps that are marked on these, since we have sharps marked everywhere else. And we're going to mark them with a bevel weight instead. Not because we're going to actually use the bevel modifier, it's just so that we have a different type of marking method on these edges so that we can easily select them later on once we eventually do a bevel on them, so that we can do inset details to them. Right here, I'm using Alt-S to inset these details further into the helmet. In hindsight, this might not be the best way of doing it. It might be better if you go ahead and actually apply the mirror modifier. I'll explain why we're going to do this. Select all the faces that have the bevels marked around them, and then put the 3D cursor to the selection so that we have a center point, then extrude all the details at the same time and scale them into the 3D cursor. I noticed once using Alt-S, it made some discrepancies between the edges as they got scaled in, as if I'm not mistaken, Alt-S is scaling along the face normals of the mesh. So it creates some discrepancies with the angles of the edges. I also use an inset here, which probably creates further problems. So it might actually be better to select the top and bottom faces that are at the ends of the scale that we do here, and then actually hiding those, making a cut through the middle, making a loop cut, through the middle, and beveling those much like we did on the visor detailing. I think that will just create less problems for you guys. Once you've done that, you can go ahead, cut the model in half again, and put the mirror modifier back on, but I just think it will create less problems for you guys, as I have to go ahead and fix up these discrepancies later on. I do show you that in case you choose to go with the Alt-S method, but yeah, I noticed afterwards that it made a handful of discrepancies that I think could have been avoided if we just used a regular scale as opposed to Alt-S. So you can see the discrepancies here that I was talking about earlier. The edges on the inner part of the detailing that we've pushed in doesn't actually line up properly with the edges on the outer part of that. So I go ahead, I use the knife tool to try and fix some of these up. On some of the other sections, I go and fill in an edge between the uppermost vertice and the bottom vertice to try and straighten it out. Then make loop cuts along those and then merge all the vertices together. You'll notice here I use the knife tool and then I go ahead and just do an edge slide using C to drag it along that normal further. So this is why I recommended just using the scale method, as I have to go and do a lot more manual work here to make the design look a little bit more consistent. In saying that though, we are almost at the end of this tutorial, and as you'll notice, the helmet has a considerable more amount of detail now. So it's really coming together, it's got a lot more character to it now. It's not just a big old blobby mesh like it was when we first started doing all this back in the 3rd and 4th episodes. It's actually got some character to it, it's got a little bit more life. We're going to keep on adding to this in the next episode, so get excited for that guys, and I will see you there.